All right, so in this video, guys, we're going to talk about the graph of a derivative. Now, I've got a very, very simple function, y equals x squared, up on the screen, and its derivative I've already found, and I'm telling you it's 2x, okay? So let's talk about what this graph looks like. And I'm going to make this a little bit bigger than I normally do. And so I've got the x and the y-axis labeled. Be sure to always label your axes on any of your graphs. I've got this parabola now that is opening up with a vertex at 0, 0. So we'll try to sketch that in kind of nice. And then I've got the y prime being 2x. Now it's just going to be a line with a slope of 2 going through 0, 0. So something like this. All right, so the black curve, this is y. The blue curve, this is y prime. So one of the things that I really wanted to point out to you guys was the relationship between a graph of a function and its derivative. Remember, a derivative is slope. And so when that graph of y prime is positive, you've got a positive slope, right? And what slope are we talking about? We're talking about the slope of the tangent line to the curve. So where is our blue curve positive? Our blue curve is positive from here all the way to positive infinity, right? That's where it's above the x-axis. So our derivative is positive from 0 to positive infinity, which makes sense because if you look at all of the tangent lines to this curve from 0 to positive infinity, aren't they going to have positive slopes? Now they're going to have different slopes, but they're always going to have positive slopes. Now, similarly, when our derivative is less than 0, that implies when the derivative is less than 0, our blue curve would need to be below the x-axis, and that occurs anywhere from here over to negative infinity. So from here over to negative infinity, our derivative is less than 0, meaning our slope is less than 0, meaning the slope of the tangent lines to the curve would be less than 0. So once again, if you sketch in a bunch of these tangent lines, these little lineal elements as I have them drawn in here, you can see they all would have different but negative slopes. And so it would be right here at 0 where you'd have that changeover from decreasing or negative slopes to positive slopes. And so this is, again, a very, very simple example, but there's some really, really cool applications in the text. And I would encourage you also to even go to Desmos and type in some more complicated functions, type in the graph of the derivative, and you'll see that anytime the graph of the derivative is above the x-axis, your graph itself should have positively sloped tangent lines. And similarly, when the graph of the derivative is below the x-axis, you should have negatively sloped tangent lines on your curve. We're going to get into much more detail with this later in the course, but this is a good opportunity to bring it up now that we're starting to study this idea of the derivative.